Yeah. All right then. So problem 31, there's a new guy here. Um, Whenever you have a logarithm that has a number in front of it, and this goes along with a different topic that I elected to not spend any time on this year, but this will be huge. So my bad. And I'll give you more practice on this if you want. But there's a logarithm in problem 31 that has a number that you might think is pretty benign. Like, what's the big deal? So there's a 4. Listen carefully. You cannot do condensing until the logs have nothing in front of them. You cannot. I'm not holding out on you here. So what has to happen is this, and this will become the most magical property that we talk about. Eventually, we're going to do some problems where this skill becomes kind of an everyday thing. But this 4 is going to magically transport itself from its current location and become an exponent on the argument. It's a property and a amazing property of logarithms that allows us to take coefficients like this and move them upstairs. And we have to do that because, again, I cannot condense those two logs, the log of 12x and the log of 3. I can't condense them until that 4 gets up and gets out of there. So the only way to get them out of there is to use the best property of logarithms. We haven't needed it yet, which is why we haven't talked about it. This 4 shoots upstairs, and this now becomes log base 3 of 81. Because that 4 went like this. He went, okay, I'm bye-bye from here. And look at me now. Woo, I'm like a magician. He reappears as the exponent of the argument. And then, of course, 3 to the 4th is 81. And now on problem 31, you have log base 3 of 12x plus a condensable log now, log base 3 of 81 equals 4. We could not have done what we're about to do as long as that 4, that pesky 4, was loitering in front of the log. It will be the only time on this practice quiz that you see it, and I regret that. But like I said, there'll be plenty, I promise you, of opportunities to practice this skill at a later date. In the meantime, moral of the story is if there's a number right here, you got to pick it on up and transport it right up to there. And now we can condense these two logarithms. So this is going to condense now into log base 3 of OMG. What in the world is 12x times 81? Say that again. So we have log base 3 of 972x equals 4. It's not this 972 that is why we're having this discussion. It's because of that move. And I hope I've made my point clear. That 4, bless you, had to pick himself up and like a magician fly up and become an exponent. Mark my words, when I'm done with you here in a few weeks, you'll go, yep, that is the most beautiful and usable and powerful property of logarithms in existence. Trust me on this. Got it? So from here, you would just water cycle out problem 31. Might as well finish it since we're going. So we're going to hit it up. It's water cyclable now because everything is condensed into single log equals a number. So 3 to the 4th is 81. So we have 81 equals 972x. And then we say it again. Did you say back to 12?
Yeah, back.
I think he's talking about problem 12. He's speaking in.
No.
No, I don't not understand what you mean, for the record. I just think it was a little cryptic. So yes, the numbers, do you see all these numbers in play here? 12, 81, 972. And what Cooper's saying, I think, is, look, we're now taking the 972 and backtracking it, dividing, you get the idea. But we know that it takes a 12 and an 81 to make a 972. So when I divide both sides by 972, the answer has to be 1 over 12. Yes.
I did this one earlier, and I just divided by 4 on both sides, and I still got 1 over. I just ignored the 4 till later.
Nice. Magic. That's neat. I'll look at those different methods with you because perhaps Oh, no, it's okay. I'll do it along with you. How's that? Does that sound good? I'm gonna end this I'll pause this and then, so I just want you guys to know that property of logarithms is gonna be your bestest buddy, okay?